fire, steel, and a sudden plunge into oil. Hardening a blade is a volatile science. Here is how it comes together. The foundation of this custom knife begins not with a pristine billet, but with heavy fabrication. High-amperage welding joins the raw stock, establishing the core mass required for the tang and bolster. The blinding arc generates temperatures exceeding 3,000 degrees, melting the edges into a single, continuous grain structure. A solid weld at this stage is absolutely critical. If the fusion is incomplete, the shock of the hammer later will simply shatter the joint. After intense mechanical pressing, the refined profile meets the anvil. The craftsman uses an angle grinder to strip away scale and slag, exposing clean steel to ensure uniform heat distribution. The billet returns to the glowing charcoal. The heat must saturate the core before the heavy hammer goes to work. Striking metal when it is too cold causes microfractures, weakening the internal structure. At critical temperature, the steel becomes plastic and yielding. Each blow displaces the metal rather than breaking it, pushing the thick stock out into a widening bevel. The rhythm is deliberate. The hammer does the heavy moving. A cylindrical anvil concentrates the force of the hammer into a smaller contact patch. This aggressive fullering technique draws the material out efficiently, thinning the edge without compromising the spine's thickness. As the temperature drops, the metal slops and the blows transition to flat refinement. The basic silhouette is locked in. Following extensive edge grinding, the steel is prepared for the most critical phase of its creation. The blade goes back into the charcoal forge for hardening. The goal is to bring the metal to its non-magnetic critical temperature, visible as a bright, translucent orange. This heat realigns the internal carbon molecules into a rigid crystalline structure known as austenite. Once the temperature normalizes across the entire edge, it is rapidly pulled and plunged into the oil bath. The oil quench rapidly extracts the heat, freezing that crystalline structure in place and converting it to martensite. The smoke signals the violent thermal shock. The steel is now incredibly hard, capable of holding a razor edge, but it is also dangerously brittle. A brief, controlled reheating draws back the extreme hardness. This tempering cycle sacrifices a fraction of edge retention to introduce crucial flexibility. The handle construction begins with a solid brass bolster. The bolster acts as a heavy physical barrier, protecting the softer handle materials from impact and sealing the delicate tang junction against moisture. Filing the slot by hand ensures a zero-tolerance friction fit against the blade shoulders. Any gap here would become a structural weak point. With the bolster seated, high-speed drilling maps out the mechanical anchor points. Steel pins will eventually pass straight through the handle scales and the tang, locking the entire assembly together. Chemical adhesives are strong, but mechanical pinning is permanent. The first tier of the handle uses natural horn. Animal horn is a dense, keratin-based material that polishes beautifully and resists moisture, making it a traditional favorite for hard-use tool grips. Drilling deep into curved, irregular organics requires constant measurement to keep the channel perfectly centered. A misaligned bore would send the tang protruding through the side wall. Calipers and depth probes ensure the interior hollow matches the steel precisely. The craftsman taps a small brass spacer into the opening to compress the joint and add a layer of visual contrast. With the base secured, the excess length is aggressively removed. The newly cut face is flattened with a heavy steel file. This creates a true perpendicular mating surface for the next handle segment. A second brass bolster is driven home, capping the horn and establishing a rigid transition line. A two-part epoxy compound is mixed and pushed deep into the horn cavity. The adhesive doesn't just bind the materials. It acts as a hydraulic filler, displacing any trapped air and expanding to fill every microscopic void between the steel tang and the inner horn wall. The handle block is pressed downward, forcing the excess glue out of the joint. As the epoxy cures, it transforms the separate components into a single shock-absorbing unit. The foundation is set. The upper grit utilizes dyed burl wood. Burls are abnormal growths on trees that yield chaotic, interlocking grain patterns. This makes the wood exceptionally beautiful, but notoriously difficult to shape without splintering. The brilliant orange dye penetrates the porous fibers, highlighting the complex internal structures. The heavy steel tang is driven deeply into the pre-carved slot, bringing the dense wood down flush against the brass spacer. A high-speed router carves a perfectly straight relief channel along the edge of the dyed wood. This groove removes excess mass and creates a nesting channel for additional structural inlay, seamlessly integrating decorative elements into the functional grip. With the upper bolster seated tightly against the burl, the entire multi-material stack is compressed. A final cross hole is bored straight through the orange wood and the underlying steel tang. This ensures that no matter how much rotational force is applied during heavy chopping, the handle components cannot shift or separate from the blade. The handle cap requires precise joinery to marry the disparate pieces. A handsaw establishes a deep vertical kerf, creating a structural slot that will house a locking tenon. Because end grain gluing is inherently weak, mechanical reinforcement is mandatory. A lateral hole is drilled straight through the side profile, and a solid steel locking rod is driven into the chamber. This blind pin acts as an internal spine, transferring impact shock away from the delicate wood joint and into the metal core. As the core assembly cures, a secondary wooden strip is cut to line the routed channel. Modern epoxy seals the insert, bonding it permanently to the burl substrate. The high-speed rotary tool then grinds the proud material away. The friction erases the seam, making the contrasting woods appear as though they grew together naturally. The raw, blocky handle must now be shaped into an ergonomic grip. An abrasive disc easily strips away the outer layer of dye, revealing the natural grain beneath while aggressively tapering the block. The palm swell and finger curves are established here. A final lanyard hole is bored through the pommel, completing the heavy material removal phase. A specialized, fast-curing adhesive secures a final metal embellishment. Once set, the micro-buffing pad sweeps across the junction. This subtle refinement eliminates microscopic step-downs between the wood and metal, ensuring the handle will not create friction blisters during extended, heavy use. Locked in the body, the entire handle undergoes systematic sifting. An orbital power sander levels out the complex tape, removing the aggressive gouges left by the angle burr. By stripping back without superficial unalignment, the sander exposes the true, stabilized grain of burl wood underneath. The block is final, taking the shape of a precision tool. Protect the intricate handlework during the final blade treatments. The wood is hermetically sealed in heavy plastic. A localized coat of high-temperature enamel is applied to the upper flats of the blade. This dark finish isn't just cosmetic. It provides a durable, micro-porous layer that holds protective oils and prevents deep oxidation in wet environments. Peeling back the tape reveals a razor-sharp transition line where the rugged, blackened steel meets the highly polished brass bolster. The dark enamel is left on the flats, while the primary cutting bevel is taken to a wet stone. The fine abrasive slurry gently removes the microscopic burr left from the heavy grinding phase, refining the geometry until the steel can sever wood fibers effortlessly. For the ultimate edge, the metal is presented to a high-speed cotton buffing wheel loaded with polishing compound. The spinning fibers act as a microscopic strop, polishing out the final scratch marks and leaving the bevel with a mirror finish. The attention shifts entirely to the handle's aesthetics. A specialized blue buffing wheel focuses on the synthetic orange resin inlay. Resin requires careful, temperature-controlled polishing. If the wheel creates too much friction, the plastic will melt and smear, ruining the surface. Light, sweeping passes gradually coats a glass-like gloss from the dull resin. This vital buffing stage seamlessly levels the transition between the porous natural wood grain and the dense, hard synthetic material. The elements are unified. The final assembly is locked into the bench vise for a thorough tolerance check. Every pin, bolster, and joint is inspected for absolute rigidity. A knife is a lever, and any movement in the handle structure during use will eventually cause a catastrophic failure. The weight distribution is balanced perfectly in the hand, ready for heavy impact. What began as a rigid, rusted cylinder of scrap metal is now an intricate, highly calibrated tool. The craftsmanship endures in the details. Form and function finally operate as one.